This is House Planning Help, episode 52. Hello, I'm Ben Adam Smith, and this is the podcast for you if you want to create a decent house, whether it's a new build or a retrofit project. I'm exploring what houses we should be building in the 21st century. Alongside this, I have my personal goal to create an energy-efficient home before I turn 40 in August 2016. Coming up in this session, my guest is Ann Pasquale from 6 Cylinder Limited. We're going to find out how thermal imaging cameras can help identify construction defects. And of course, there will be an update on the documentary on airtightness that I'm trying to crowdfund. You guys have been absolutely brilliant, so there will be a progress report, and I'll do my thank yous towards the end of the podcast. Before we get stuck into our interview, I have a really nice iTunes review from J Mango in Canada. It says, "Great podcast for builders of the 21st century." That's the title. "This is my favourite podcast. Ben, your energy and enthusiasm are conveyed very well and your experience shows. It's great to hear someone so passionate about building. Excellent overview of the Passive House standard. I wonder how many tons of carbon this podcast will save via its inspiration." Oh, I like the sound of that. "The interviews are top notch. I'm just getting started, but I was surprised and pleased to hear Sarah Suzanka, Martin Holliday and Wolfgang Feist, to name but a few. Also, really enjoyed the client case studies." Well, that's what we're trying to do, just help anyone who's setting out to build a house or to do some remodelling. So thank you, and there's always room for one more. We particularly love those ones that come in from other countries, whether you're in the Middle East, Australia, China, South America, the States, anything like that. We would love your review, and it does boost us in the rankings and points newcomers to this content. Today's episode is about thermal imaging, and I'm going to dedicate this one to Nathan Burlton. I don't think I've ever done a dedication as such before, because this isn't content that Nathan has requested, but I know that he's interested in thermal imaging, and he's given us a ton of support in terms of retweets and sharing links of the Kickstarter campaign. I'm slightly wary of singling anyone out, but Nathan, you've done an awesome job, and it hasn't gone unnoticed. So my interview is with Ann Pasquale from 6 Cylinder Limited. You'll hear how passionate she is about creating better buildings and trying to spot issues on site before they develop into something worse. I got underway by asking how she got started in construction.
All right, I'm an architect by training, so I have a bachelor's degree in architecture, and after several years of working on site supervising construction works in Boston, I went and got a specialist master's in building physics and building performance from the Architectural Association. So I did about a year of heavy calculations into how buildings actually perform in terms of thermodynamics, energy performance, and fluid mechanics in terms of air movement in the building. And because I had spent so much time working on construction sites, seeing where everything tends to go a bit off the rails, I was possibly my professor's least favourite student, because I kept poking holes in his theories about how buildings should be built by saying, well, no, if the chippy does this wrong, then that's not going to work. And if the window installer doesn't do this right, then that's not going to work. And if you don't coordinate this, and this all at the same time, then that's never going to work. And just picking holes in all his beautiful theories about perfect construction. And he kind of said at one point, oh, well, if you're so interested in how things actually get built, why don't you go be a post-occupancy evaluator or a building performance evaluator and forensically deconstruct why things do or don't achieve their performance goals. And lo and behold, I went and did that and absolutely loved it, because I could go and find faults with buildings where things had gone a bit off, and then from my background knowledge kind of understand where the mistake had happened and where the miscommunication had happened and miscoordination and whatever else, and then work with the teams to help resolve those issues so that they don't happen again on the next project, and ideally also help fix the building at hand as well. So I mostly do forensic work into building performance and understanding why buildings do and don't work, and then helping design teams and project teams actually fix the problems.
Well, I approached you to try and find out a bit more about thermal imaging. So let's just start at the beginning. What is thermal imaging?
It's a type of photograph, essentially. And so, the electromagnetic spectrum, which is what we see part of the spectrum as visual light, the lights that you see every day. Thermal imaging is actually very, very similar, only it's not at the same visual spectrum we normally look at. It's at the infrared spectrum, which is a slightly different wavelength. So that's specifically looking at the heat of objects. So if you point a thermal imaging camera at your hob when you've just cooked a meal, you'll see it glowing nice and red. Likewise, if you open your fridge, it'll be black or blue. So it allows us to see difference in thermal temperatures. Where it comes in handy in buildings is we tend to use them in winter to look at the thermal performance of the building envelope, which is the walls, the windows, the roof, the floor, anything really that goes from inside of the building to outside of the building. And we specifically look for what we call thermal anomalies, significant differences in temperature that you wouldn't normally expect. So you'll expect a wall to be more or less a consistent temperature from top to bottom. So you'll expect that to be all the same color. If you point a thermal imaging camera at a wall and you see a big dark spot on the top or the bottom or somewhere in between, there's something obviously going on that's causing a cold spot somewhere on that wall. So it might be a bit of insulation that's been missed out. It could be a bit of damp. It could be a piece of the structure that's sort of bridging from front to back. So there's all sorts of different reasons that you could see that. But what helps with the thermal imaging cameras, if you look at that same wall with just your eyes, it looks like a normal wall. The only way that we can see the actual thermal differences is with the thermal imaging camera. So it helps us identify construction defects, design defects, general aging issues with buildings. So it's quite good if you're doing a retrofit. Say an eave has developed a bit of a failure point and some water has started to kind of seep into the building fabric and soak one of the walls quite heavily. You'll be able to see where that is in the structure and be able to identify it so that you can remediate it, fix it before you go installing anything further. So it's quite useful to understand what exactly is going on with the fabric before you start engaging with it.
Does the cladding of a building ever stop us from getting a good view of what's happening?
Yes, there are certain situations where what we call a rain screen, which is generally a bit of cladding that is a certain distance away on the outside from the rest of the building fabric. So there's a bit of an air gap in between the insulation and most of the structure and the rain screen. That does make it very difficult from the outside of the building to see if there's a problem. It will mask a lot of the issues. So with rain screens, it can be quite difficult to see exactly what's going on and if there are issues with the insulation or other things. That said, you can actually see quite well from the inside if there's a problem. Because the nice thing about thermal imaging cameras is you can see problems from either side of the wall usually. So you can see them sometimes quite clearly from the inside, sometimes quite clearly from the outside, which is why when you do a survey, you want to do it quite comprehensively, all the interior surfaces and all the external surfaces. So you might see a bit of insulation having been scooped out of a wall on the inside when you look at it from inside the home. But if you stand outside and it's a rain screen facade, you won't see that same issue.
I'm getting the impression that this is something that we do at the end, particularly in your introduction. You were saying you're a forensic, going around spotting all the problems.
CSI buildings.
When ultimately should we be doing this, or it's a checking tool?
It depends on the project exactly as to when you do it. So if you are doing a retrofit where you're going to have to start ripping into walls a bit, especially if you're insulating an existing property which might be a bit damp, I would highly recommend doing thermal imaging before you start applying insulation, before you start doing really anything to the facade or the external walls, is make sure you're quite certain you know exactly what's going on. And if there are areas that are a bit of a concern, look into deconstructing them a bit and seeing if you need to remediate them, because there's no good reason to go sealing up some nice damp building fabric inside of new insulation. It won't do you any good. So in retrofit, it is quite valuable to do it beforehand. For new build, I would highly, highly recommend doing it, if at all possible, during the construction, if you can get the right conditions. And this gets a bit tricky because you do have to have the timing quite right. So if you can get the heat system commissioned and ready to go, whilst it is still winter outside and still a bit cold, and then you crank the thermostats up, get the house nice and warm, turn them off for a couple hours, let the building cool down a little bit, and then go and do the survey. Hopefully before you've put the furnishings in, before you've put drapes up, before you've lined your radiators with your socks and whatnot, because then you'll be able to see quite clearly what's going on with the building fabric. Once you start moving furniture in, it becomes much more difficult to see it. That said, very few construction schedules happen to work exactly on that timeline. So if you can't do it before you move in, but after the heat system's been commissioned, you can do it the soonest winter while the building is still in defects and you're still involved a bit with the contractor. And that does help you identify construction defects where just things have been accidentally missed out. It's relatively rare that we see something that's blatant negligence on the part of a contractor. We do occasionally pick up things that you just think, oh, you really shouldn't have done that. But it's usually just someone's forgotten to do something and they just have to go back and fix it. So it's very, very common to find at electrical sockets that the electricians have gone and scooped out insulation to install a socket or something behind a wall. And they've just not put the insulation back and just kind of slapped a plate over the wall. And so you see a big cold spot right behind the socket. So you can just send them back and say, oh, you need to put some more insulation back there and fix it. And usually they're relatively minor fixes. You can find some far more serious issues which are built into the design. And that's really around detailing, where you've got sills or headers around windows which are very poorly detailed, which then conduct heat directly from inside to outside. Those show up quite clearly. And they're a risk not just in terms of energy performance in that the energy is being transferred out of the house quite quickly. They're also a bit of a risk in terms of condensation, because condensation is effectively caused by having a colder surface in contact with warm, moist air. So if you have warm, moist air in the house and you have a cold bridge, say, above a window, that surface is going to be a bit colder than everything else. So water is going to tend to condense there. And that's how you're going to end up getting bits of mould. So if you look at UK houses quite commonly, you'll see mould tends to form in the corners of party walls and external walls. And that tends to be a very common thermal bridge in traditional buildings. It's always been there. They've been building them that way for centuries. And that is the bridge that tends to cause the most condensation. And in modern buildings, we as much as possible try and design that out.
Who is the person who does this? Because I know you can get thermal imaging cameras, but then perhaps you're not going to know what to do with them. Or is this the architect? So who is the person who controls this process?
I'd say it's not at the moment, it's not a particularly well-established practice. It's not super common to do it. It's becoming more common, which is really positive.
With low-energy buildings?
Yes, with low-energy buildings. And some architects are becoming very proactive about getting a few people who understand how to use the camera out there and doing this quite regularly on their buildings. I'd say they're by and large probably the minority. There are people who are certified in doing this as a service. I've had mixed experience with contracting to some of them, because one of the concerns is when you subcontract this out to a guy that shows up with a camera and takes some pictures, if he's not really invested in the process and the construction and the client and the product, you tend to kind of end up with a bit of a drive-by survey where they stand outside, snap a few photos, stand inside, snap a few photos, and they don't really take the time to understand what's going on and look for specific details that might be an issue. The person that you want to hire would be someone who understands the construction or takes the time to understand the construction, look at all the details, look at the site pictures and see how the building's been constructed, talk a bit to the architects and the contractors to see how things were done, and then who takes the time to do the survey in a very, very proper and methodical manner. So the conditions of the survey should be done in very specific weather conditions. So you don't want a nice sunny day like today, unfortunately, because the sun will heat up the external wall of the building. That will show a bit differently and cause different patterning than you would expect from a normal, an overcast day. So you want an overcast day, which is at least 10 degrees colder outside than it is inside. So you can artificially boost the internal temperatures by just running the heat system for a few hours, nice early in the morning, get it nice and toasty warm inside, and then just switch them off. So you let the radiators or the underfloor heating cool down for a few hours before you go in with the camera. Because the trick is, I've seen quite a lot of flyby surveys where they've had the radiators still running. And the slight problem with that is the radiators kick off so much heat, you can't see anything that's going on the wall above them. all you can see is what the radiator is warming. So yeah, you want to have the right site conditions. You can't have a rainy day. You can't have an overly windy day. Sometimes the best way of doing it is to just go to the building very late at night. So show up at 11 o'clock at night. The nice thing about thermal imaging is because it's infrared spectrum instead of visual light spectrum, it doesn't matter whether it's completely dark outside, you can still see the building just fine. The only problem is you can't then take visual photographs to show what you're looking at. But yeah, going to the building quite late at night is one way of doing it. Also, I tend to go very early in the morning. So in the dead of winter, showing up to site at 6 a.m., which is a bit tough, but you get a very good picture of what the building is doing because it's been out of the sun for at least 12 hours. It's sort of normalized to its temperatures. So yeah, you want someone who takes the time to do the work properly. And you also want to make sure that they understand how to calibrate the images properly. The images they are actually calibrated photographs. So you can put a crosshair on the image and see the exact surface temperature of what's underneath that crosshair. Now, most building materials emit heat at a particular range, which is actually quite high. There's different materials which emit at different rates. Now, for building materials, if you're looking at bricks, woods, concretes, those sorts of things, they're all in the sort of 0.9 plus range. They go from about 0.9 up to 1. You can generally lump those all together in one range and calibrate those images just fine. However, if you have a facade that has quite a lot of shiny metals on the outside, so if you happen to have a zinc facade or something really nice and exotic, that has a very, very different emissivity. And if you put the crosshairs on a material like that, it's going to give you a false reading. And this did happen on one occasion with some architects that were looking at the thermal performance of a building fabric before it had been clad. So they were looking at the nails that had been driven through the sheathing on the outside. And when they looked at the image, they saw these bright, glowing nails. And they said, oh my gosh, the nails have all these thermal bridges. And I said, no, it's just you have to calibrate the wood separately from the nails and like the same temperature. And we went through and recalibrated a couple of images and I showed them, no, the nails are the same temperature as the sheathing. So you want to make sure you take the time to calibrate the images right so you don't get false readings and sort of send someone down a blind alley.
What are we wanting from the report at the end?
From the end, what you want is usually a little bit of a fix list for the contractor. So where things have gone a little bit off and they've missed bits of insulation or things like that, they can go back and remedy it. So that's one thing. It's a bit of a quality assurance process to make sure that they've ticked all their boxes and done things properly. Because there are instances where things just get covered up on site quite quickly and you can't always pick up where something's been done not quite. So
right. What do you mean there? They cover something up and then you can't tell with the thermal imaging?
You can't see visually. So generally when architects do inspections of sites, they do visual inspections. So we look around at the sheathing, we look around at the insulation, we look to see things mostly look fine. And usually they do. And so one particularly fantastic example was a courtyard of a children's centre. We were walking around just actually having a play with a thermal camera. We hadn't even told the contractor we were going out with it that day. And we were walking around and we kind of swung the camera in front of a wall out to the courtyard. And there was something seriously wrong with this wall. It looked like it was just hemorrhaging cold air into the space. The architect and I were both kind of standing there staring at it going, oh my gosh, what's going on? We pulled the site manager over and he really quickly realised what had happened. And he'd had a guy who had been supposed to be sealing up around the windows and doors and putting sealing tape in between the frames and the walls. And apparently he hadn't done it. So the guy had just kind of slapped some trim around, slapped some cladding on. That whole facade just wasn't really airtight. So as soon as we kind of showed the picture to the contractor and said, okay, we're going to have to take this apart a bit and fix it, he immediately just said, yes, absolutely, yeah, that's fine. And they fixed it the next couple of days. But those sorts of issues, had we just been standing there without the thermal imaging camera, we could not have seen what was going on. And the problem with especially an issue like that is where there was quite a lot of ceiling missing. There was quite a lot of cold air that was getting pulled into the building. You're going to end up with a lot of condensation inside that wall had it not been fixed. So we would have ended up with mold on the inside of the wall, condensation, rot, because it was a timber cladding. So it would have actually degraded that facade very, very quickly because of that pretty substantial construction defect. And it was not something we could see at that point in the construction. We could have seen it 2 weeks earlier before he had clad it, but not after. As you can imagine, had the wall degraded, had it rotted, had it had mold issues and whatnot, the client would have been obviously quite justifiably upset. It would have cost a heck of a lot more money to go back and send someone to fix it after that had all happened. Whereas fixing it then and there, it was just a matter of pulling a few trim pieces out and putting some tape back in place and putting it back together. So it was a relatively inexpensive fix compared to had it waited for 8 months. And then also we didn't have any issue with the client complaining that something wasn't right.
Is there any other factor about thermal imaging that we should be drawing in here?
I think one of the most important things is understanding that it's a tool. It's not an end-all be-all tool. So you still need a bit of intelligence about interpreting the images. And that's one thing I've found people tend to overestimate what thermal imaging can do. You still need a person who understands what's going on to interpret the image properly. Otherwise, it'll just tell you there's an issue here, but not exactly what it is. There are instances where we do have to deconstruct to understand what's going on. That can tend to be more of an issue around roof joints with walls, eaves and whatnot, because it's sometimes difficult to tell whether you've got moisture ingress coming in through that area because there's something wrong with the moisture barrier, or if it's just a bit of a thermal bridge because there's a beam up there or something like that. So sometimes you'll see an anomaly on an image and not be able to see it clearly enough to know exactly what's going on. If it's a concern where you start having mold in that area or something else, then it tends to be worth actually taking a little bit of the wall apart and having a quick look and seeing if something else is going on. But no, it's a pretty interesting tool that's quite useful, both in terms of just finding construction defects and understanding the state of an existing building. But also I found it's quite useful for design teams as well to understand what they've done, because you do occasionally have instances where they've done a detail which, okay, could have been a bit better, and they just think, oh, well, that's fine, it's good enough. And then they see the thermal image with a big glowing thermal bridge under a window or over a window, and they're just absolutely shocked at how horrible it looks, and very quickly spend the time to figure out a different way of detailing that kind of a wall section.
What would happen if we decide not to do any thermal imaging?
It's a bit of a risk. Is you would tend to know about it. Is you will find condensation. That's the thing it tends to pick up the most, is areas where you're at risk for condensation, mold, rot, and that sort of thing. So you will find out about it eventually, but unfortunately you'll find out about those issues after they've become a problem and started damaging the building. More importantly, it's really a matter of quality assuring the construction. So it's about making sure that what you've paid for is actually what you got. The trick with building performance is really, it's all in the details. It's about little issues that can go a bit wrong, which end up causing actually some pretty catastrophic problems a couple of years down the line. And this is one of the tools that actually helps you identify those problems before they've become serious issues with the fabric or the structure or anything else. So it's a way of just double and triple checking that things are working the way they should.
And one final question, if we actually have to go out and find the people to provide this service, are there any tips on how we choose someone who's going to do a good job? You mentioned earlier some of these people who just take some snaps here and there.
Yeah. I'd say that's one thing to actually talk to your architect about before you hire them, is if they're familiar with doing this process. It's quite a useful kind of discussion point when you're interviewing them. Are they familiar with doing a thermal imaging survey? Do they do it in-house? Do they work with someone who can do it? Because if this is something that is completely foreign to an architect, I would be a little bit hesitant about working with them to design a low-energy building. If they've never put a thermal imaging camera across their building, then they're going to learn some bad lessons the first time they do it, or some rather harsh ones at least. So I would say that should be definitely one of your interview questions with your architect. There's other people that can do it. I would say there's a handful of passive house and specialist architects and consultants that can do it. I would be a little bit hesitant about people that do this solely as a service day in and day out, because it does tend to be a bit of a factory, that I've seen at least, of people that just sort of drive by, snap a bunch of pictures, hand you a report, and then walk away. And it is quite useful to have someone on the team that actually has a camera to hand, because it can be useful in different stages of the construction as well. And if they have a camera to hand and they can bring it to site once in a while, rather than just a one-off survey, it's actually quite useful to maintain a constructive dialogue with the contractor as well. So there's been a handful of times where I've used a camera where I've never produced an actual report. I've just taken a handful of photographs of things that need to be remedied, and then just sent them to the contractor and said, okay, here's where we found the issues. Can you have a look at these? And he's just gone off and done it. So we didn't have to produce a formal, comprehensive report to get the issues resolved. And I think really that's sort of the sensible way of approaching it. Is it should be a bit like when the architects normally go out and take pictures of site. We don't go then handing a report of all our photographs back to the client usually. We just pick out the ones where there's clearly an issue and we talk to the contractor and we resolve it that way.
Well, I'd like to thank you very much for your information today, and I'm hoping we'll be able to get a few of these photos into the show notes, because of course it would make sense. Lisa, thank you very much.
You're welcome.
Yes, this topic clearly is about images, so it's one thing talking about it, but you might as well see it too. houseplanninghelp.com/52. We've got all the key information from our discussion, and there's a link to Six Cylinder Limited. Perhaps you've got a question or a comment, you can leave that at the very bottom of the show notes. I have a question for you, particularly if you've been through the process. How has thermal imaging helped your project? I would like to know. Before I wrap up for today, I did mention I wanted to say a big thank you to everyone who has helped in our Kickstarter project. This is the first time I've ever tried anything like this, and we are a third funded already. That just in 6 days. It's unbelievable. So we've raised nearly £1,800 at the very moment that I'm recording this. Our target is £5,500 and we have 34 backers. I've also reached out for help from a few people from the Hertfordshire Mercury, which is my local newspaper. Tree Hugger, I had a quick word with Lloyd Alter and he was able to mention us in an article, which certainly helped. The AECB, the Passive House Trust, and also, get this, Wolfgang Feist, the co-founder of the Passive House Standard, has been tweeting about this, and at the end of his tweet he put, important project. So very happy about that. Feeling the pressure slightly though. My call to action is, can we increase the number of backers? It's not just about the money. This is about validation too. So if we can really get the number of backers up there, if you're listening, perhaps you can't part with a lot of cash, but we would love your support. Just another name on there. Oh, this is something that we want to get made. So if you can do that, yeah, really, it's just about every pound counting, every name adding up and creating something that is significant. Spreading that message, we want better houses, and we know that there are still a lot of shoddy houses going up, which can't happen in the future. Next time, my guest is Mark Tiramani. He built the UK's first certified passive house. I was lucky enough to stay in it a few weeks back, and I had a chat with him about PHPP. He's not an expert, but he's got a really interesting story, and that's why I wanted to hear it from him. So we'll be talking about the passive house planning package. I hope you can join me for that one next time. Cheers.